So back to trigonometry in junior high or middle school or high school or whatever we did it. Our turtles, and pretty much every other kind of graphic that you display on the screen that's a two-dimensional set of graphics, has got an x component and a y component. The turtle graphics work like this. They're zero-based. The numbers get larger as you go to the right, and the numbers get larger as you go up. So if you bought some graph paper, it might be numbered something like this. Now on our screen, actually that's 0.00. So as you went that way, you get negative, or you get negative. That's the x-axis, that's the y-axis. Or when we're specifying values, we typically say that that number goes first, and then that number goes first. So that would be 0, 0, or well, let's go back down here. 0, 0. This would be 30, 10. This would be 10, 30. That kind of thing. Right offhand, I don't remember why all those are called Cartesian coordinates. I'm sure it has something to do with cartography. So our final goal is to draw Mr. Bear. Yeah, we're paying big bucks to learn how to draw bears. So what we need to do is figure out, you know, if we drew the bear based on the coordinates that I'm going to provide you, it's going to be an itty-bitty little bear on the side of the screen. And that's not going to be too cool. So we're going to have some code that would draw some stuff, but it would make it a little circle, not in the correct place. But we're going to modify the code to shift it to be in the correct place without changing the data, and then blowing it up to fill the available space. So if you have this Word doc open, what coordinates is this point at right here? What is its x value?
10.
It's at 10. The y value is at 30. Don't know why one is red, one is green. It doesn't matter. Now, in the code that I'm going to give you, you might think that the origin of the circle would be right in the center, and that's probably how you would do it in geometry. But the way the turtle works is when you're sitting at a certain point, if you were facing north and you told it to draw a circle, it would draw it from there and then loop all the way around. I said north. I hope that that's what it means. Anyways, so when we're specifying the position of our circles, we're going to do it from the right edge, not the center. That's why I drew a circle there. So what are the x and a y coordinate of the origin of our circle using this system? Its x is 40, its y is 20. Its radius, well, radius is half of the diameter. What does it look like its radius is? Did I hear it? Okay, if you can't see the numbers, you need to have this on your screen because this is what you're going to be turning in. And it's 15 because we go from 40 to 10. 40 minus 10 is 30. It has a diameter of 30, which means it has a radius of 15. Why do we care? Because when we call the turtle circle function, we specify the radius. So, let's tackle drawing a bear. But first, we're going to do a simplified version. These will be the pieces that we tackle first, if we get them all done. We're going to draw 2 ears, 2 eyes, a head, and a mouth. That's not going to really leave you much to do. However, I'm going to give you a second shape that I also want you to draw, all on your lonesome. So here is what we want to do based on that. We're going to need to figure out all these coordinates. Ear 1 starts where? What is his coordinate? About. Looks like it's about 2451 to me. Something like that. Doesn't have to be exact. If you disagree with me, if you think it's 25 or something, okay, go with what you want. And what's the about the radius of this thing look like? I'm not totally convinced it's 10, but I can't tell you why. Well, I guess if it's going from 22 to 38, that's like 16. Divided by 2 is 8. I'm going to say it's 8. Maybe it's closer to 9, I'm not sure. If it was 10, it would go all the way. You know, it would be 20 in diameter. Now ear, what am I doing?
I was like, you're not.
Yeah, I
looking
think
at
you're
the
looking
right
at
one.
eye.
Okay, I won. No, I'm kidding. All right, ear 1 is at like 2451. I had that right. And his radius was 25. What do y'all say? Pardon me? Maybe 10? Yeah, let's go with 10. I could kind of waffle and say maybe 11, but meh. Ear 2 starts here. He really ought to have about the same Y. So, you know, his Y is going to be the same. His X is going to be different. It's going to be at about what?
65.
We actually want to go from the circle, though, not the center. So, yeah, it'll be 77, maybe? 76?
76.
Same radius. And the head. The head starts here. That one's pretty easy to mark. 70, 30, pretty much. And what's the head's radius? I'll leave the hard one for y'all to figure out. Well, it goes from, yeah, right, because it goes from 10 to 70, that's 60 wide. Divide that by 2, that's 30. Alrighty, we have a bunch of code which we're going to save time and copy. So create a new idle document. Copy all that. Paste it into idle, file, new file, paste. I'm just going to call this one bear 1 in case I decide later to come up with a bear 2 or something. If you have the PDF, no, you don't have a PDF. Were you able to copy it, everybody, or do you have problems with it? You should be able to click inside the rectangle. Is that working for everybody? The reason I don't distribute this as a PDF is if it's a PDF and you try to copy it, it loses all the indentation. Alrighty, once you do a save as, you ought to be able to run it, and it's not going to do a dang thing. Oh, well, I drew some crosshairs. Ooh, and it drew a circle. Okay. Let's go look at what's going on. There's a function here called circle. It's not part of the turtle class, but it uses the turtle class. Let's scroll back up to the top to get a better idea of what it's doing. Up here at the top, we have import turtle. We make a turtle where t is equal to turtle.turtle, like always. We set the width of the pen to 1. We set the speed of the turtle to 9, which is pretty fast. If you want to make it as fast as possible, you change that to a 0. And then we hide the turtle. We hide the turtle so that we can't see the cursor as it's drawing. We just see the line. There's a couple of functions here. One's a relocate function. If you want to move the turtle from one place to another on the screen, you don't always want it leaving a path as it moves. That's what relocate does. Relocate takes 2 parameters, an x and a y coordinate. So when it goes x, it lifts the pen. And then it moves to the x coordinate, it moves to the y coordinate, and it puts the pen back down, ready to draw. And for good measure, it sets its heading 90 degrees, which is north, so that we're always sure of our orientation after calling relocate. Otherwise, you know, the position of the circle might vary, differ on the last direction. And we don't want it to. We want it to be consistent. So along with the relocate function, we have a circle function, which accepts 4 parameters, an x and a y, which is that edge of the circle, a radius, and a color. So in order to get it to that position, it calls the relocate function. Then it changes the color. It begins a fill, it draws a circle of the specified radius, it ends the fill. Then the crosshairs is just something I threw in. I'm not going to even bother explaining it much. You could look at it and figure out what it's doing, but you can see that it's calling forward. It sets its heading to 0, which is off to the right, and it draws a line. FD stands for forward. Then it sets the heading for 90, which is straight up, and it draws another line, so that makes it crosshairs. So down here in main, the first thing it does is, bless you, it draws the crosshairs on the screen, and then it draws a circle at position 100, 50. Now that's not part of our bear. We don't have any blue circles in our bear. But that's just to demonstrate how to call the function. So, let's monkey with this for a minute. Let's make this a circle at 0, 0, right in the center of the screen with a radius of 50. And you go, well, that's not really what I hoped for. I wanted it to be centered. But we said start at 0, 0, draw a circle, and according to this particular implementation, the origin of the circle is on the far right edge. We don't really want that circle. I'm just going to comment that line out. I'm going to kind of leave it for a reference. But we came up with some coordinates for the first 3 circles of our bear. So if I go back and look here, our coordinates were this: ear 1, ear 2, and the head. I wonder if I can get these on the screen at the same time. So, our first circle, ear 1. Circle starting at x coordinate 24, y coordinate 51, with a radius of 10, and that's ear 1. And I forgot to specify a color. The color tan is really pretty lousy in this implementation. I think I recommend a different color. Now I don't remember. We can go and look at that color list. Alrighty, let's draw another ear. Circle 76, 51. These are commas, not periods. I was mistakenly typing periods. Ear 2. And now for the head. Circle at 70, 30 with a radius of 30. Tan. If you feel like making a Grateful Dead bear with all sorts of rainbow colors, that's fine with me. Okay. So that's the head. If I don't have any typos in that stuff, it should draw 3 circles, kind of like a Mickey Mouse face. Yeah, that's pretty small. We're not impressing our customer yet. Our customer will buy the software only if it's a big bear. What could we do to fix that? Well, we could change all these numbers. We could go back to our original graph, and make a new graph and put the bear on it with the numbers changed. But we can also do what's known as scaling. Scaling is you don't change this data, but you multiply the coordinates by a value in order to blow them up or in order to shrink them. Because if we multiplied all these coordinates by 2, it'd be a much larger bear, right? I mean, it'd be much larger circles. We could do that by hand, but I don't see a good reason to do that. Yeah, let's do that just for one of them. Let's do this for the head, just manually. We're going to wind up deleting this, but I'm multiplying all those coordinates by 2. Alrighty, so we can see that, by multiplying our values is a pretty good technique. But we also want it centered. That's called shifting. I'm going to delete that line. I don't need that circle. Alright, so copy the code. We've done that. So shifting coordinates. Our bear is tiny. It's in the wrong place. It's in the upper right coordinate. We want it in the center. So we need to learn about shifting. What we want to do is, if we have a circle that we specified here and draw it, we really want it here. This is kind of arbitrary, but these values do work for the bear that we're drawing. So every value that we pass in needs to be modified by a certain value to get it from here to here. We're going to need to subtract a certain value from x to get it from there to there, and we're going to need to subtract a certain value from y to get it from there to there. And the numbers we're going to pick, like I said, are arbitrary, but it will center the bear. And what do I mean by arbitrary? If you had a different shape, if you drew something that was much wider or whatever, you'd have to shift it by more to get it into the center of the screen. And you just have to figure out that shifting value yourself. So the shifting values are the difference in the coordinates, the difference in the x coordinates and the difference in the y coordinates. C1's x coordinate is at 50, 30. C2's coordinates are at what? 10, 0. So to shift from one to the other, we're going to want to subtract 40. And to shift the y values, we're going to want to shift by 30 pixels. We're going to want to bring everything over 40 pixels and push everything down by 30. Bless you.
Bless you.
Scaling kind of works the same way. If we have a little line that goes from here to here, but we want it to be twice as large, it's going to go from there to there. What do I mean by that? Well, this guy's coordinate right here in this system is -20, -20. We want it to be stretched out to -40, -40. These don't line up right. But anyways, and this is +40, +40. And that's +20, +20. So we can kind of guess what we need to do. Assuming that this is perfectly centered on 0, 0, that's indicating pretty much that these 20s are going to become 40s, so we can multiply. Why not add? Adding was for shifting, moving it left, right, up, and down. Multiplying is for making it larger or smaller. Okay, so here's the original line and its new line. B2's x-coordinate is at what? 40. B1's x-coordinate is at 20. So B2 divided by 1 is going to give us our shift factor. We may decide to actually make a larger shift value after we play with this. We may decide that doubling isn't quite enough to make a good looking bear. But according to the worksheet, we have decided that our shift values are -40 for x, -30 for y, and that our scale value is ×2. Let's go look at which function would be a good one to modify to accomplish that. I think the circle function would be a good one. When we call circle, we specify an x and a y. Then there's a relocate. I'm kind of afraid of monkeying with relocate. I think I want to leave that one to 0. I would rather change x and y before we call relocate. So we decided that the shift for x was -40. So shift x is equal to -40. shift y is equal to negative 30. Do I have this backwards? No, negative 40 and negative 30. So x equals x plus shift x, or why not just x plus equals shift x? Save ourselves some typing. X plus equals shift x. Y plus equals shift y. And let's run it. This doesn't handle scaling yet, but at least maybe our bear is going to be in the center. Pretty good. I don't know. Kind of looks menacing with the crosshair right in the middle of the bear head, but we'll live with that. We can comment out the crosshairs when we're finally done with this. Now let's handle the scaling. We decided that our scaling factor at this point was 2. So after we have calculated x and y, let's do x equals x times scale and y equals y times scale. I could shorten those to say x times equals scale and y times equals scale, just like I did for the shift x's. Well, that did not work. What did I do wrong? For a moment I was confused. I see what I did wrong now, but can you take a guess? Something else needs to be modified besides the x and the y coordinates. Yeah, the radius, because if you blow up the size of the x and the y's coordinates by 2, we better multiply the radius as well. So let's add one more line down here. Radius equals radius times 2. That should do the trick. I want to look at my document again and see what colors I recommend. Surely I did. No. Okay, I think the tan is okay pretty much for a light brown color, but if we make the inner ear dark brown and we just call it brown, it's going to look pretty nasty. Let's kind of prove that point. Let's draw the inner ear now. His coordinate is at 52, nope. 22, 51. So circle 22, 51 with a somewhat smaller radius. Yeah, let's go with a radius of 8. And let's make it brown and see how nasty that looks. My recollection is that this looks pretty bad. We might want to pick a better color. Yeah, see, that brown looks like red to me. You can leave his ears red if you want, but let's find the color list. If you look up TK colors, then hopefully we can pick a nice brown. Saddle brown looks kind of good. Sienna is the one that I actually wind up going for, which is spelled with 2 N's. So I'm going to erase this word brown and change it to Sienna, S-I-E-N-N-A, and that's my inner ear. If you're making a green bear with pink ears, that's totally cool. Anyways, That's better. It's still kind of small. Why don't y'all change the scaling factor? Make it 3, 4, 5, or 6, or 10, or whatever, and see what size you think it ought to be. I'm going to wander around and make sure everybody's got the bear rocking. That's good. What scale did you choose? 7 looks good. Yeah, yeah. Right. Well, you can upload the Word document. There we go. Cool. What you use? 7. 7's good. It looks like yours is a little bit bigger than 7. Yeah. 7 seems to be a good size, wandering around. You didn't have to pick 7. Okay, we have progressed enough, actually, that you could finish the rest of the bear yourself, in my opinion. Anybody getting syntax errors that they need help fixing?
Do you mind just going up? I don't have the radius. I didn't have that. Okay, so it's radius times.
There we go.
Radius times your scale.
What did I do? I made it times 2 when it really should be times scale, just like you said. So for everybody who did radius is equal to radius times 2, like I did, fix that. I didn't see anybody's who looks messed up. I think everybody fixed it already. I'm going to change mine to a scale of 7 as well to match y'all. So to finish drawing the bear, which is your homework assignment, and I'll actually let y'all work in it in class, and if you get it fixed, done by the end of class, it's totally cool. But there's one more thing I want you to draw, write your own program to draw after this. Let me show you what it is. If you can stay 10 more seconds, I'll show you. This was my tally of which ones were most popular. Okay. I'm going to ask y'all to draw that. Can we think of a more appropriate thing to draw with a turtle library than this? I can. Okay. So the homework document is going to have the picture of the bear. I'll just cut and paste it, as well as this. Now you're going to have to kind of draw your own grid lines or something like that. I'm making it a little bit more challenging, but I'm sure that y'all can figure it out.